Dr. Zucker presents
Multivariable closed-loop control. Contents of this video.
Considered as a regional purification plant of N equals 7 pumping stations, which build a 15 km long network. Each pumping station affects all other stations in the network. The multivariable control system for entire network, in the following called MIMO, is described in the books of Dr. Zucker. In this video is shown an example how to design the MIMO control system for 2 pumping stations. The block diagram of the MIMO plant with N equals 2 pumping stations has no feedbacks and is shown in so-called p-canonical form.
Identification. Identification means that the following 4 transfer functions of the MIMO plant should be defined: main transfer functions and coupling transfer functions. We have to apply 2 input step signals. First, we apply the step to the actuating variable y1 and measure the step responses from the red shown blocks. The table with measurement results is shown. Then we repeat the experiment and apply the step to the actuating variable y2. The step responses will be measured from red shown blocks. The table with measurement results is given below.
The identification with MATLAB upon given files with measurement results is shown in this video sequence.
The identification of the main plant G11 is finished. Now let us define the error of identification. In other words, let us compare the identified model with the real plant. The MATLAB Simulink model for such comparison is shown below.
Further, we will define the main transfer function G22 and coupling transfer functions, repeating previous operations. More information about identification and MATLAB scripts you can find on the website of Dr. Zacher.
Part 3. Separated control. As far as you have defined all transfer functions of the MIMO plant, you can choose the types of main controllers and define their parameters for separated control.
Separated control means that we ignore the coupling transfer functions, A12, and A21, as shown in figure A below.
In this case, we will use the standard tuning rules described in books of Dr. Zacher and shown in his videos.
Here is shown an example of the separated MIMO-Control and step responses after steps of both set points W1 and W2. Why is the control so bad?
Because by the separated control we adjusted controllers R1 and R2 upon figure A, ignoring the coupling. But in the reality, there are the coupling blocks A12 and A21 as shown in figure B. In the real plant, the set point W1 affects the variable x2 and the set point W2 affects the variable x1. That's why the control is so bad.
If we simulate the MIMO loop not upon figure B, but upon figure A, ignoring real coupling, the control should be optimal. That means, the controllers R1 and R2 are optimally adjusted.
Yes, that's right, it is shown below. The connections of coupling blocks are deleted, and the control is optimal. But for the real control we should use the decoupling controllers, as shown in Part 4, or the new blocks, called router, as shown in Part 5. Part 4. Decoupled MIMO-Control.
Decoupled control means that we doesn't ignore the coupling transfer functions A12 and A21, as shown in figure C below.
The coupling transfer functions A12 and A21 should be compensated by decoupling controllers R12 and R21. In the books of Dr. Zacher and in Automation Letter is described how to define the parameters of decoupling controllers.
Here is shown an example of the decoupled MIMO-Control and step responses after setpoint steps.
Part 5. MIMO-Control with router.
The router is a new element of closed-loop control. It is described in books of Dr. Zacher, in Automation Letter and in videos about bus approach.
A router consists of two blocks, the main plant and the plant inverse. The inputs of the router are the output of the main controller and the controlling variable X. The output of the router is the actuating variable Y.
Here is shown an example of the MIMO-Control with router and step responses after setpoint steps.
Part 6. MIMO-Control with router versus MIMO decoupling control.
Let us compare the MIMO-Control with n equals 7 variables with router and with decoupling control. For the decoupling control there are needed 49 controllers.
For the MIMO control with router here are needed only 14 controllers. That's all about MIMO control. More information you can find in books of Dr. Zacher. Thank you for attention. Goodbye.
Goodbye.